Adam, can you hear me?
Yes, I can hear you.
All righty. Very good.
And I'm going to step away from the mic just for a second to make sure that the recording is going properly.
Yeah, that sounds good.
Oh, if you could talk for a sec while I'm away, that would
sorry.
be helpful.
God, a very rare request. I'm actually being asked to speak. Normally I'm being asked to shut up. Do you want me to do the standard thing of telling you what I had for breakfast? All right, and so folks that are just joining us, definitely. Wait, is that a what? Brian Cantrell, identify yourself. That is normally.
Do you have your super fan on?
No, that is normal. Yeah, that's my 13-year-old. My 13-year-old, that is not my 13-year-old, but my 13-year-old, in order to troll me, invented an account, B Cantrell #1 fan. Synopsis: I'm just B Cantrell's #1 fan, and then he likes the tweets that he thinks are lame, which is like it's so pernicious.
It's good. Sounds like somebody's son.
Hey now. That is, I have to say, it is the worst when you see some attribute in your brood and you realize like they're getting that from watching me.
It's even worse when you get blamed for it.
I get blamed by, yes, exactly.
By my spouse.
By your spouse, exactly. That's right. I know. It's like, or like, yeah, he said something that you would say. I'm like, wait a minute, but I didn't say it. I had the prefrontal cortex that told me not to say it.
Yeah, still your genetic fault. Yeah.
All right, Brian Cantrell, I've asked you to be a speaker, and I'm sure that you and I have gone through. Did he leave? He left. He left. Did it happen? No, he's there. This Twitter Spaces does not make this part easy. But I'm sure this person has gone through life. I mean, have we gone through life being confused as one another? This is still how my daughter spells her last name, by the way. So
I have received mentions for you in the past, but haven't engaged.
Wow. I'm sorry. I think I'm sorry. This is really.
You don't need to be sorry.
Okay. I am sorry. My name, obviously, I feel that I have spent my life correcting the spelling of my first and last name from your name. I feel everyone wants to spell my name as your name.
I guess I win then?
You do win. No, that's exactly the right attitude. You actually do win.
Brian with an I admire your restraint because I get confused both for the Adam Leventhal, who's a British sportscaster, and I readily reply to his bank, which has the wrong email address for him, and to the American Hockey League. Whenever people are very cranky with officiators, I always like their tweets or weigh in and explain that our referees are as good as we pay them and things like that.
And it should be said that you are actually holding up an American Hockey League jersey in your profile photo.
Yeah, I mean it is a reasonable. I mean, it's a reasonable confusion to think, I guess, that like some dude wearing a jersey speaks for the league.
I mean,
but yeah,
you relish this confusion.
I mean, only during Calder Cup season.
Is the Calder Cup? Is that obviously that's the American Hockey League Cup?
Yeah, it took me a while to learn this, but yes, and the Checkers are my favorite team.
Where are the Checkers from?
I think I knew that was giving that. I think they're from Nashville, but I might be confused.
The last, I don't know if it was the last minor league hockey, not the last, a recent of the like 3 minor league hockey games I can think of that I went to was at Roger Faulkner's wedding. Actually.
Oh my goodness!
Were you at that wedding?
No, I wasn't. It was in Michigan, right?
It was in Michigan. It was in Grand Rapids, Michigan, which is, if you are ever in Grand Rapids, first of all, I definitely would recommend catching your Grand Rapids Griffins as they take the ice. It was like in October of 2001, so it was very like going to a minor league hockey game felt like a very patriotic act. So it was very post 9/11 kind of a thing. And then we also went to the Gerald Ford's Presidential Museum is in Grand Rapids. I don't know has anyone been to what? Go ahead.
Oh no, go ahead.
No,
This sounds
please,
like
you go ahead. No,
this
no,
is,
no.
this is like
You want to make some denigrating remark about Gerald Ford, and I'm here for this. That's okay. I guess I would have
I
made
was
the
actually
same
going to say.
denigrating remark.
This sounds like your dream come true, is what I was going to say.
Okay. Well, you right. I should have known that was not a denigrating remark on Gerald Ford. That's a denigrating remark about me. That actually makes
Yeah.
even more sense.
No, not at all. I think just you live for those moments. I think I remember you trying to rally the crew to go to the Gerald Ford Museum.
Well, and I was being very Gen X and snarky about it. In that, like, it's like I wonder how prominently they're going to feature the fact that this is our only non-elected president, right? Gerald Ford never won an election. Gerald Ford was he was the Speaker of the House. He became the Vice President when Spiro Agnew was rightfully nuked from orbit, and then became president when Nixon resigned. And I'm like, I wonder how prominently they're going to feature that. And you walk into the Gerald R. Ford Presidential Museum, and you get about a foot in, and inscribed in stone in letters that are like a foot high are the excerpt from his inaugural address where he says, I recognize that I'm the only person to not be elected to this office, and the responsibility that he felt to the American people to represent the whole American people. It's amazing. So I came out like, I went in a Gerald Ford cynic, and I came out a Gerald Ford super fan.
Really leaning into it. And just for context, Roger Faulkner, his wedding in Michigan, our late colleague who invented the proc file system, among other things.
Yes, the inventor of the proc file system. When Roger's goal was to be the oldest living hacker, and he may have succeeded. He was definitely, Roger has passed, but definitely died with his boots on. And he would always say that I'm not sure if Tom Linen was here. I'm not sure if Tom had any. I don't think Tom may have just intersected with Roger. Roger was coming out of that AT&T heritage and was at AT&T working on Unix. And as he said, I met Sun because Sun is Unix headquarters. That's what. Tom, did you intersect with Roger at all?
I don't think so. I don't think I ever met him.
I think you'd remember. So a story that, God, this is I mean, Roger has many. There are many Roger Faulkner stories. And when Roger died, I wrote an obituary for him for Usenix, and I convinced Usenix to make the paper that he wrote with Ron Gomes on the /proc file system freely available. And that paper, I think, have you read that paper anytime recently, Adam?
Not recently, no. But I mean, I remember years ago.
It's a good paper. I mean, and Roger viewed it, as he said, I am on a mission from God to make programs debuggable. I thought that was pretty great.
You know, that was definitely the zeitgeist of that I fell into when I started at Sun, and was sort of like fortunate and unfortunate enough to be in a bunch of Roger's code. A 22-year-old wondering why some jackass had used a linked list instead of an AVL tree, and kind of being slapped down time and again, being like, "Well, we didn't have that, back in the day, and 5 watch points was enough for anyone."
You were wondering why he was using a linked list and not an AVL tree.
Yes.
Okay,
yes,
good. So
yes,
I was going to
yes.
call bullshit on that story.
Oh no, he never used anything except for a linked list.
He never used anything except for a linked list. Preferably nested linked lists. I mean, the order of n squared was the way he liked to roll.
Yeah, at least, right.
And I mean, performance is the root of all evil is a Roger Faulknerism. And he viewed performance optimization as, I mean, he was not trying to make his code passable, but he also viewed it much more important that the code be correct than the code be fast, if you had to choose.
Yeah.
As we pointed out, like, you actually don't have to choose, and this code could be correct and fast, but you've chosen to make it correct. So you had the temerity to code review him into an AVL tree.
Oh, I wandered into like code that Roger had abandoned years ago. For example, with the Solaris watch points, I remember in particular.
Oh God,
where he had done some kind of very cursory thing where there were a bunch of sharp edges. For example, so watch points, were regions of memory where you wanted to take a trap when the user program modified or read or whatever, and it was really fun stuff because it's all this virtual memory stuff. But for example, you couldn't have overlapping regions, and the system wouldn't really tell you that. You would just sort of find out the hard way. and it searched, take a fault and then search this linked list of watch points. So it was fine when you're sitting at the debugger entering them by hand, but when you started having automation insert watch points for you, for example, when you wanted a watch point at the end of every allocated region, it didn't work so good.
It did not work. That was libwatchmalloc, right?
Yeah, exactly. So libwatchmalloc just was a dog after your 10th malloc.
Right. It's called libwatchmalloc because you'll be watching every malloc as it unfolds in front of you.
That's right.
Glacial pace.
But
watch points are magical, right? When they work, it's magical.
Yeah.
It's like
it's very, very cool, and very useful and very slow, even with an AVL tree, because you're trapping and remapping memory and single stepping and trapping again. But when you need them, man, it's very hard to imagine alternate mechanism.
To be able to say, when is this memory modified? And when this memory is modified, I want to stop the program, or I want to take a core dump, or it feels like it felt like a superpower when it works.
Absolutely. And I think that the thing that Roger instilled, certainly in me, and I think in all of us, you and Mike and the other folks really interested in debugging, was how this kind of debugging stacks, where once you make these layers reliable, then you start building automation on top of it, like libwatchmalloc, and that then exposes some of the shortcomings of these mechanisms you initially thought were just going to be manual. But to Roger's point, then there's plenty of time to optimize once you've proven that these mechanisms are really useful and valuable.
Yeah, that's actually a good point, and I had not really thought of it quite that concisely, that Roger made this incredible contribution about debugging infrastructure being an attribute of a production system.
Yeah.
And so for those of you who have, if you've used strace, which traces system calls on Linux, strace is, I'm pretty sure that it was following in Truss's footsteps, although, Tom, maybe you have to let us know if 4.x had, I'm not sure what 4.x did for this, but Truss, which was to, it was to trace, it was originally TRSS, right? To trace system calls and signals. What did 4.x use to trace system calls, Tom?
I don't remember. I remember implementing an strace thing back at Amdahl.
Oh my God. And this is on Unix on their 370.
Right.
And was that ptrace based?
Yeah.
Oh, ptrace. Such a
talk about slow.
And also ptrace. So for those of you who don't know, ptrace is the historic debugging interface in Unix that ultimately /proc replaced. It's still what you'd use in Linux to debug. You use /proc for system information, not for debugging, and you use ptrace for debugging. And ptrace has a couple of fatal interface flaws. Have you ever dealt with ptrace, Adam?
Yeah, a bunch on Mac OS. Yeah, and it's a huge pain in the ass. It's awful.
ptrace in particular had this idea that you should be using the wait system call to wait for ptrace events.
And just like overloading it.
Yeah, overloading it.
Very strange. Yeah.
It feels like, doesn't it feel like there should be like one word for this in German? Do you know what I mean?
Yeah, there's sort of misappropriation of the mechanism in like a seemingly clever way.
Yes.
But one that is ultimately a disaster.
Yes, that's exactly it. What is the one word for that?
What's that German word?
For those of you who are German software engineers, please hop in and tell us the one word for this in German that explains, because no, that's exactly it. And I feel
but in defense, there was like no form at all of inter-process communication back then.
Okay, wait a minute, Tom. Are you actually going to defend ptrace's use of wait?
No.
You may want to think carefully here. You got a legacy to protect.
But there was some mechanism in the kernel that they hijacked, right? So
okay, so that actually is interesting, Tom, because that is so. In that era, your argument might be that the system call space was so sacred that you couldn't. And you can also use ioctl, I guess. You had to use, because the problem about using wait is to wait for child processes, which one can argue whether they should have named it more concretely, more specifically.
Yeah.
But that is just death to overload that with ptrace.
Yeah, it was basically wait for an event from somebody.
Josh, would you like to say something about ptrace?
I'm trying not to.
There you go. Good luck. So
It's the manual page. The interface, from what I recall, is documented as like specific integers that you pass to the thing.
oh yeah.
I feel like it predated the use of like define.
Well, and it's an interesting object lesson too, because Torvalds talks about ptrace in like, I want to say like 2001, where a bunch of people are complaining about ptrace in Linux, and he's like, look, it's just, we're too far in at this point. Like, we can't replace ptrace. We're just going to have it forever. And you're like, man, that was like 20 years ago. Like, I bet you could have replaced it 20 years ago. Doesn't that feel like it's just an interesting reminder in terms of like, this stuff doesn't need to be immutable.
I mean, over the course of 8 years at Giant, there were definitely times where it's like, we could fix this, but it'll take years before we can actually use it because everyone's going to have to update and move past the flag day and a bunch of other stuff. But then looking back, it's like, it's been 8 years now. Could have probably changed things back then. At some point, it's been 8 years, then it's been 20 years, and it's been 30 years. You can actually add a parallel improved path, even if it takes forever to get off the old thing. Like,
ptrace is the x86 of system calls.
It is.
right.
The thing you have to remember is that computers are growing exponentially, so the best time to fix anything is always right now.
Well, that's it.
Right.
I mean, the best time to plant an abstraction is 20 years ago, but the second best time is today, right?
But it will always it's always worse to wait another minute.
Yeah.
Brian, I feel like this is a long coming apology because I was realizing the other thing that I did, the other like kind of a super fun site I left for at Sun that you guys carried into Joyent was this emulation of ptrace in branded zones. And so just because there are a bunch of like keywords there.
Are you trying to make Josh scream or cry? Is this some sort of Stanford prison experiment that we're doing with Josh?
No, I feel like if I apologize in public, then he can only be so mad at me.
Are you saying you're doing this in public so I won't make a scene?
That's right.
That's right.
Well, look, Josh, don't make a scene, okay? Like, accept the apology. Like, he's trying to.
Is that the calculus?
Yes, that's exactly the calculus. So Solaris had zones, and we created at Sun these branded zones that would pretend to be Linux. And the way we did it was, I think that my Joyent friends will tell you, wrong. And I don't think so. It was amazingly functional. Well, right. And the way that we emulated ptrace was with a shadow process that would use /proc and then do this sort of half-baked emulation of ptrace. And then, Josh, the thing that you'll really hate me for is that
already does.
I think I think we were granted a patent for this benighted mechanism.
I didn't see that one coming. Josh, I didn't know anything about that. I don't know. He's on his own on that one.
Did you get a hat? Did you get a hat that said patented on the hat?
I think I have a plaque even.
Oh, good.
San Francisco man, I guess now Alameda man, found bludgeoned with plaque.
That's right.
As I say, we've determined the murder weapon. That's
exactly.
Good.
He was actually murdered by his own patent plaque. Wow.
Yeah.
Someone must have been half crazed.
And actually, to bring it back, Brian, I think it's the application of this German word that we're looking for, which was exactly that, like this clever application of existing mechanisms that ultimately and maybe immediately was a disaster.
So I don't think I would because with ptrace, you're trying to do something very hard, and this is just in general very hard. We found over and over again, when you're emulating one system on another, and Tom, I know you've got a lot of experiences on this too, you are having to emulate a system's bugs. I mean, I feel like as the one emulating the system, you feel like you are thinking about the semantics of the system more than the original implementers thought about it. And I think whether you're emulating x86 or you're emulating a different kind of operating system, I don't know, Tom, what do you think about that?
Oh yeah, you got to be bug for bug compatible with each thing.
And I feel that, like, for me personally, it was the vfork that when we learned that Go was very dependent on the vfork semantics with respect to signal disposition, which is like vfork unsafe at any speed, toxic at any quantity. Signals unsafe at most speeds, toxic in many quantities, and like to take the confluence of them is unconscionable. And yet Go somehow manages to depend on it, to this day, deliberately. And it's like, so you're, as the system emulating this, like, yeah, you got to find a way to make that work. So I don't know, Adam. That I don't think. Maybe I'm just trying to serve as your therapist here, but I don't think that. I mean, Josh, maybe you can use an "I feel" statement when you talk to Adam about how you felt about inheriting a half thought out p-trace mechanism.
Use your words.
That's right.
I think that I feel.
That's it. That's better. Doesn't that feel better?
The part that I remember being most frustrating was, so the reason we even cared about it was not for strace, if you recall. It was for Ubuntu's short-term attempt to be a systemd. It was for Upstart.
Oh, it was for Upstart.
And they were using it to track, or attempt to track correctly, process lifecycle across double fork boundaries by using ptrace to intercept all of the forks, right?
You were already making Adam feel so much better, because Adam is already like, dude, I was the least of your problems. Like, that is
seriously, that's a mess.
Right. But so, like, the emulation that we had was pretty thin, and I think may have been dependent on signal delivery or something that just stopped happening in the context. And so, like, it was just we wouldn't do the thing that it was looking, and so Upstart just didn't work at all. It wasn't like it crashed; it just never got any of the information it thought it was going to get.
But it's kind of
that turned into a lot of surgery to implement it with sufficient fidelity that processors couldn't escape.
Right.
And it had to work. It had to work just like the real one. And in the end, we did get, on the back of that emulation, we did get strace to work basically correctly, I think.
It worked so remarkably well. It worked so great. I'm gonna get in the show notes. We'll put the tweet of us, a bunch of, like, basically non-drinkers all hoisting a beer when Josh got this working, because it required us to put all of that in the kernel. I mean, it was insane.
Well, we were trying to lift, if you recall, we were trying to do stack switching to begin with.
That's right.
And the emulation, because our original model for LX was that the in-kernel component was basically a trampoline. It would save some registers on the user stack, a bit like signal handling, and it would just always return you back into this shared library that we had secretly mapped into the Linux process memory space every time for every system call. And so things like ptrace emulation could happen in the context of that user library, and it could make any native system call that it wanted and go figure out a bunch of stuff. When we moved to stack switching, we also moved to some system calls would be emulated entirely inside the kernel, and the kernel would be involved in knowing which emulation stack to drop things onto, and it abridged very heavily the emulation path, which made things go a lot faster, but it also meant that the whole of the existing ptrace emulation, which itself opened a bunch of proc files and did things, just wasn't going to work out.
And Josh, you may want to explain why we had to do stack switching, because that itself is kind of an interesting story. That's a course Go.
It was they were using the red zone, right?
Right, they're using segmented stacks, and we were. Mm-hmm. I mean, this is why it's so hard to live as an emulator, because
the Linux system call ABI is passed by register with no stack requirement, and our emulation was not like that.
It was you basically cannot you can't live in the user level stack at all. Like, you just cannot.
Right. Because we would use whatever the stack was, whatever your existing stack, we would put things on your stack, which is normally okay because C processors usually have abundant stacks. And the fact that we use it, you can't tell if you don't know to look. Because we put it all back.
We put it all back.
After we return control.
As far as you know.
Yeah.
Yeah, right.
Right.
Yeah, and I remember we also had, so we would have these bugs where it's like, hey, this application works on Ubuntu and it doesn't work on LX, or it worked, or even worse, like this application used to work and now no longer works. And I remember one of those that was also a real object lesson for me was where application core dumped, but was a regression. We upgraded the operating system, the application core dumped. And of course, all right, well, that's a clearly a bug. What's going on? Well, it turns out it wasn't as clearly a bug because the application was implicitly relying on phishing in its own stack and relying on effectively, it was relying on data corruption. It was relying on the fact that this value would be 0. And it's like we needed to push in additional value onto the stack in order to work around one of the Intel bugs. And in order to do that, it's like, yeah, the value you're phishing is no longer 0. Now it's non-zero, and now your application is core dumping. You're just like, oh god, it's so hard when you.
Do you remember what Closure Common Lisp did with the context, the M context, and the U context?
Yeah, right.
They would copy it somewhere else.
Right.
No.
Yeah,
No.
which is technically legitimate, as it turns out. It's just that we had stashed in the stack all of this other ancillary information, the real information. So we would give it the emulated version of this information, which was about the Linux emulated process state, and our second like real native stack stuff that would happen on a signal or whatever would not come along for the ride because it didn't know that it existed.
It didn't know the ride happened. It didn't know there is a ride.
So I mean, these kinds of lies just don't nest. So that U context or N context are collecting register information. So if you've got some shadow copy somewhere else.
Yeah, and we collected really good information. It's just that we also collected, additional secret information that we would.
Yeah, and this is one of the lessons I feel we learned.
And with the emulation stack, the bad thing was so like we had moved the collection of that information to a more secure location, but you still need to. Unfortunately, the part that we would put on the emulated processor stack, which by this point was separate from the emulation stack, which was somewhere else, you still have to chain them all together. Like you have to pop the same number of contexts off the emulation secret stack as you do off the native emulated thingy stack. Anyway, it was a mess, and we did it. I think we did it with magic values and fishing expeditions.
It was bad
as a fallback.
Why isn't that a performance problem?
You don't want to take signals at an audible frequency, I think, in general.
You don't take signals at all. Signals are such a...
Yeah, if you can avoid it, but like...
Signals are just
CCL at least took a lot of signals because it was from an era, I think, where programs were single-threaded, and when stuff happened and you wanted to handle it, it would be because of a signal. Possibly a nested signal.
But programs, and I get the abstractions were lean, but programs that use these abstractions in a load-bearing fashion, I think it highlights one of the things that we've seen a couple of times, I feel, in my career, that magic does not layer well. When you got someone in the stack being magical, they're kind of relying on people elsewhere in the stack, like, not being as magical.
Yeah, playing by the rules.
Playing by the rules. And it's like, well, why should I play by the rules? Like, you're not playing by the rules. It's like, but one of us has to play by the rules.
And if we had unlimited resources and time, right, I think that the final end result of LX would have been to move all of the things into the kernel. So that there was no user space visible thing that had to happen. And signal handling, our signal handling occurs about half in the kernel and about half in libc, in our like a Lumos libc. So like getting to the point where we can do emulated Linux signal handling entirely in the kernel was going to be a bunch of work, and we just never pulled on those threads.
Well, so I'm always curious because I talked to the Microsoft folks were very inspired by our work, and so they like the WSL, the
WSL1.
WSL1 was directly inspired. Like, you guys showed that like this is possible. And I felt like, man, do you regret following us down this path? Like, I'm sorry if we led you down the...
Well, they did because they stopped.
They stopped.
Right?
I know, they realized.
Wait, what's WSL? Sorry.
The
Windows
LX
subsystem.
Yeah.
The Windows subsystem for Linux.
Oh.
Which the name is on backwards, but it's like an emulation thing that lets you run unmodified Linux binaries on a Windows system in a kind of context of some sort.
And I think like
Folks, can I ask a question?
Yeah, go for it.
Is it what is the state of running Illumus on M1?
Like on an ARM CPU.
Yeah, that would be
On an Apple.
on an M1. That would be a go for it. That's not. Yeah, there's
No one is going to tell you it's impossible, but it's not.
It's definitely not done. Yeah,
it's not going to happen before dinner.
No, but yeah, sure. Nothing happens before dinner, right? Or a lot of things can happen before dinner. But I guess
if you had a
question
ThinkPad, it could happen before dinner.
we can get a
Right,
ThinkPad
but
before dinner.
it's just an ARM PC, isn't it?
Yeah, we don't
So
really
my
do.
question is,
We
I
don't
guess,
really do
like, there
ARM
could
today.
So my question is, there could be different solutions to that, right? There could be like QEMU, or there could be just booting up an operating system.
I mean the thing with
The
the
virtual
M1
machine story on M1 is like I cannot have like a VirtualBox, right? Because it's M1 and
You would need a full system CPU emulator, and it would run very slowly, I would think.
And Laura's our resident ARM expert. She can weigh in.
Yeah,
not
the
really
M1
with
is
ARM.
fast. The M1's really fast, and Kimu is pretty good. So you can do amazing stuff with pure emulation.
Laura,
The thing with the M1 is that like it's not fully standards compliant. I know I'm sending people around hissing whenever I say this, but it actually turns out the fact that Apple is kind of doing their own thing makes trying to boot up an operating system that is not OS X like a lot of work. See also the work for Linux to try and get what's actually merged with the Linux kernel, for example, moved in. It's basically just a bare skeleton. And how long they'll take anything else, remains to be seen. But I think there's been a lot of controversy there. So, I mean, it's certainly a labor of love, I think, to try and do it. But, yeah.
Laura, can I ask you, how do you feel about, personally feel about M1? Does M1 feel vindicating, or does it feel like threatening to kind of the principles of ARM in terms of the openness, or maybe both?
I mean, I'm happy to see it going forward, but I also kind of have strong opinions about running non-Apple operating systems on the hardware. Like, I support everyone's right to try and do so, but I think it is not the best use of effort to try and do this, mostly because exactly Apple has, chosen to make it difficult to try and run anything else. So I think you're fighting an uphill battle, and it doesn't seem like it's worth it to try and do anything else.
Which was also true on their x86 systems. I mean,
yeah,
like it's always been kind of crap to run Linux or BSD or something else on like even relatively old MacBook Airs or something like that.
But what if there was like a virtualization layer somewhere? Like, I don't know.
It's hard.
I mean,
it's hard because it's hard to get the machine really properly emulated. And I mean, I really, as Laura can attest, when we were starting to do Cortex-M based development, I really, really, really wanted QEMU to work for full machine emulation, and it's really spotty and tough. So it would be, I think an M1 emulator would be great. I think it would be hard to have a complete emulator.
The thing that amazes me is AWS has a macOS offering for people who want to do cloud development, and it's just a bunch of Mac Minis strung together.
Yeah, I think I saw a promo video.
You would think if anyone could get Apple to virtualize macOS, it'd be AWS. But they won't do it.
I don't believe that Apple virtualize inside a whole lot necessarily. Even like you would think.
You've got VMware Fusion, right? Where you can get
but that's got to run on OS 10 already.
Right.
So maybe some longtime Apple watcher can give kind of insight into this, but it is kind of amazing that the world's most successful single computer company in terms of Apple, has really never kind of grokked or had interest in the server space. I mean, other than X1. Adam, did you have an X1? I think we had an X1.
No. I mean, I know I was a big an Apple super fan back in the day, but no, I never had an X1. I was going to do a throwback to the Chirp systems because I thought you were going in a different
Chirp.
direction.
Yeah.
And their clones. Like my brother had a like a Power Mac clone. I can't remember the actual name of it. Power Computing. There it is. And then just yanked it all back when Steve Jobs showed back up.
Yeah, so the Chirp was the common hardware reference platform, right?
That's right. And it was like ostensibly, I think, with IBM to create this open PowerPC kind of standard thing. I think I don't think it got very far.
I mean, this is obviously the alley-oop from Mike Sullivan's laptop. I don't know if you're trying to take me there or not, but a colleague that I worked, it was in the next office at Sun, was responsible for a bunch of build infrastructure, and his laptop was stolen, which was very weird. This is what is now the Facebook campus. So if you're on Facebook, you're in MPK 17. I wish Facebook had renumbered the buildings. I just feel like I feel it's like disrespectful for the dead. Like, you're living in the carcass. Like, can you at least anyway?
Have you seen the sign out the
Oh,
front?
I know the sign that it's very it's fetishizing the dead. I feel it's like, let's bury the dead. Let's not fetishize them.
You can go on a pilgrimage to what feels really honestly like a graveyard in some kind of Sleepy Hollow thing.
A graveyard that is like a flooded
through little
graveyard.
trees. There's a clearing, and then you see like
Right.
there's a body
definitely a
hanging
Day
from a
of the
tree,
Dead.
and like
Day of the Dead vibe as you walk around certain places. Yes.
So anyway,
Planet of the Apes.
Mike, that's right. Mike's laptop was stolen, and Mike's laptop was actually a PowerPC laptop running Solaris 251. A very ill-advised experiment because we'd done the endianness wrong. We did a little endian port, not a big endian port. And so we were the only little endian PowerPC implementation on the planet. There were only we had fewer than 20 machines that could boot Solaris 251, and one of them was stolen. And I would have loved to have been like, what happened to that laptop? If I could have like the webcam on the adventures of that laptop as the thief realizes that they have the actual most worthless laptop you could possibly steal in 1997. As they attempt to, it's like, this is the only operating system it can run. It's a terrible it's an operating system for which there are no binaries other than like CDE.
It's in small pieces at the bottom of the bay at this point, I assume.
Yeah. But you were vindicated because years later, Open Power is Little Indian.
Open Power is little. I don't think I realized that Open Power is Little Indian.
Yeah, to get the Linux stupidity compatibility.
I have a
Really?
question.
Yeah. Sorry. Go ahead.
Brian has a talk that is on YouTube that is like a gathering of a lot of old Sun folks, I think.
Yes.
It seems like it. And there's a story of a laptop there. Is that the same laptop?
That's got to be the same laptop, I'm sure. Are you accusing me of retelling stories? Because
No. I wanted to get the
No, I think that is the same
I
laptop.
found that talk really, really interesting. I don't know what I found about it interesting, but I found a lot of things about it interesting.
We're all living fossils talking about.
Don't accuse him of reusing stories, or we'll start hearing about the H programming language.
Exactly. Hey, listen. That's called language H. First of all, and you're gonna really regret. You don't play with fire, Aaron. You can't just bring up language H and then walk away. We were talking about the Friendly Orange Glow, this great book by Brian Deere last week, and one of the characters in that goes off to NCR and works on a COBOL-like language at NCR, and I'm like, oh my god, this is language H. This person went to work on language H, so I want to go. Yes, I want to go hunt down some language H.
I mean, it's sorry. I have to just bring this up. There is also, I don't know about language H. I guess I need to do a little bit of
No,
research
you
on
don't.
that.
Actually, no, you really don't. It's a language that you haven't heard of for a reason. Don't worry.
There's another language that I've heard of, and it's the D language.
Yes.
The D language that is. So I actually looked at the D language, the D-trace D language, and I don't think I've poked around that much because, unfortunately, there is a bunch of D-trace hooks in Mozilla's SpiderMonkey, but they're not maintained anymore.
Yes.
So that was the closest that I had an encounter with, and I was like, okay, time to do some D-trace. But I couldn't get that experience. But I did learn a little bit about the D language and the demo with diagnosing the funky behavior in one of the components in GTK or X11, which was delivered at Google.
Yes, that was the D
I
trace
have
review of
some.
Google. Yeah.
Yeah, so I feel like the D language that kind of like programs dtrace.
Uh-oh. Is that me? Or is that
That's a
him?
cliffhanger. No, that's him.
That's him. Okay.
him.
So I've upgraded my app. You'll notice, do you notice that we're 40 minutes in and I've not died?
Impressive.
It is impressive. And
Yeah.
the one of the Spaces folks DM'd me saying, "Hey, you may want to upgrade your app." So I did that, and so here we are.
There you go. Good.
So
40
of
minutes
course,
later.
when Nima stopped, I was just like, "Oh my God, it's happening again!" I'm traumatized by. I thought he was actually going to talk about.
It is about the time it usually happens.
It is about the time. I thought he was going to talk about Walter Bright's D, the other D, the frankly the more famous D language. And do you remember our interaction with Walter Bright, Adam?
No, I don't.
Walter Bright's D, Walter Bright of Borland and C++ fame, and the D language, like much more D-lang, much more, I think, much more famous than dtrace. But our D and his D were developed in parallel and in secret. And when we talked about dtrace and D, he's like, "Well, this is interesting, but you're going to have to change the name of the language because I've got a language called D." And we're like, our language, first of all, is not Turing complete. So come on, you can't take us very seriously. 1, 2, it's a letter of the alphabet. I don't think you can copyright those. I don't think you can I think you got to pick a more distinctive name if you want to have something defensible. So
plus, it's it's the one after C. We're both going for the same pun here,
right?
So...
And it's not that funny. I mean, it's not
right. Right. That not that funny of a joke. Right.
It's not that funny of a joke. We don't need to fight over it. We can both just have the same not funny joke. But D is RD, very inspired by awk.
Yeah.
Of course. I mean, it all comes back to awk. I mean, Tom, awk must have felt like just an absolute blast of modernity when that happened.
Yeah, that was very cool. I was right there that summer. It was all coming together. So yeah, people were doing crazy stuff with it.
So you're there with, you got what, Weinberger and Aho and Kernighan all developing this together.
Right.
Was it named at that point? Had they?
Yeah, pretty early on.
I
don't remember when.
I mean, it's kind of genius to use are there other Unix commands that are named after that have an ode to the authors in its name? I don't know.
The Bourne shell?
It's true. The Bourne, I guess maybe this was a thing.
But
I mean,
but
and
it
before
was
that, the Thompson shell, right? I mean, I guess it's not in the name of the command, technically.
Yeah. It's the Bourne shell because of the way it was written in Algol 68.
It is not the greatest C.
No.
It is not the greatest C. I love Steve, but Jesus Christ, Steve. It's not Algol.
Yeah.
You can't do what you like. It's wrong. What you did is wrong. For those of you who've not been into the source code, pound defined begin as open brace and pound defined end as close brace, if I recall correctly. John.
Oh, yeah, and
much worse than that.
A bunch of the rest of the language,
Yeah, what was worse than that, Tom?
Well, he had all kinds of Algol 68 constructs, so the source code was not immediately identifiable as C.
Because it was all in capital letters and if and phi and then and a bunch of other stuff that.
See, in the world of programmers.
I mean, the use of the shell also has all those algorithm algorithm-isms in it.
In the actual language.
Yeah, the if and phi and all that stuff.
Right.
Case and ESAC, right?
Right. Those are algorithm. Yeah, I guess I hadn't really put two and two together on that.
I'm so sorry. My phone died, and I just lost the past 5 minutes of the conversation.
Don't worry, we were just waiting for you to rejoin, having a fight or flight reaction because I assumed that Twitter Spaces had actually died on me again, which it hasn't because I've upgraded the app. So I'm optimistic that it's not going to die.
I guess it's okay because we experienced that last week, and it was fine.
And the week before, and the week before. It has died every time.
It is still amazing how
But
bad the
this was
visibility is on Android. If I want to know, is this app leaking memory and slowly linearly growing to its own death? That's actually kind of hard to tell on an Android.
Okay, so that's not just me, because I actually have tried. It is, unfortunately, with Twitter Spaces, it's very hard to do anything else on your phone while you're in that Twitter space. But yeah, so Android, I wanted to look for better tools for that. They don't exist.
There he went.
I don't know. What is people's preferred HTOP for Android?
Yeah,
I think we lost.
Tom, we've not lost you. Have you lost me? This is.
I lost you for a minute. You're
Okay.
breaking up.
So sorry, Nima. You took a 5-minute vacation, but I think you were asking about the dtrace of UTalk at Google Circa. That's actually, yeah.
Yeah, I guess I built a lot of I built a lot of context because there was this probably very selfish of me, but I guess it's a question that I care about a lot. I guess in terms of dtrace is like such a highly domain specific language, right? But in terms of ergonomics and how you can sort of declaratively just say what you want and just collect data and in various different sorts of way, I was feeling more comfortable in the dtrace language than I was like.
Uh-oh. Is that me again?
So I was wondering. Can you
Yeah,
hear me?
but Twitter Spaces knows you're trying to praise us, so it's trying to cut you off. I kind of admire it. It's got some new filters for it. Knows you're trying to praise D.
Okay, I guess.
Yeah, we can hear you.
Can you hear me now? So what I was saying is that in terms of like working with a language that aggregates data and formats it and prints it out, I have found the entire like dtrace experience very somewhat ergonomic compared to SQL or VisiCalc. But it surprises me that dtrace is such a domain-specific language. Even though it's like querying operators and aggregating operators are pretty generic. Like you can think of the same kind of syntax over a relational database, right? So I was wondering what went into designing that sort of like high-level layer that programs dtrace. Like who was behind it? Like was it an iterative thing, or were you inspired by SQL and gave it like a different syntax? Like what went into
Not
it?
inspired by SQL, although maybe, and actually in terms of Adam's personal career, Adam, I think I dare say like the SQL came later for you, right? I think
Absolutely.
Yeah. So
for sure.
Very much inspired by awk for sure. We were talking about awk. Definitely took great inspiration from awk and its ability to very quickly put things together. And then in terms of the aggregating operations, honestly, that just came out of using it. And I do feel like this is one thing that is like really important for anything to be ergonomic. I feel its creators really need to make use of it. And we used dtrace a lot to debug lots and lots of things. We were the biggest users of dtrace, Adam, I dare say. Correct me if...
Yeah, no, I totally agree with that, Brian. And I think that, and if you agree with this, but I don't think any of us was really a programming languages nerd of any description.
No.
And one of the things that was very stark for me as I look as some of the dtrace clones and sort of offshoots emerged is how much more structured some of the language was and how much more boilerplate they required and how much more fussy they were about a lot of things that the D language is not that fussy about. Mostly to its benefit, to its ergonomic benefit, but occasionally just to like total misfortune. But to your point, Brian, it was all based on like us exploring some phenomenon, something being kind of a pain in the ass or impossible, and then inventing something that was easy to use.
And it was all about that actual use. And so we were optimizing constantly for our own use. And I think it was like awk in that regard. And what I didn't realize at the time, and Adam, do you remember like when we were going in from our architectural review board, one of the comments was, honestly, this reminds us a lot of awk. And we were like, that is high praise. Thank you so much.
Right.
These Peter Weinberger is an idol. And then you realize, like, oh, wait a minute, that's not intended as praise. That was actually intended as, like, damnation, because awk, from a PL perspective, I think is viewed somewhat pejoratively. I mean, if you're a PL person, like, correct me if that's an incorrect inference, but I think awk is viewed somewhat pejoratively, and it shouldn't be, because it's so pragmatic, and it is so easy to stitch things together, and it obviously, and Tom, I would love to know, you were there in that summer. I mean, you get the sense that awk was being used by its creators to do things.
Oh yeah, it's basically, it's kind of like what's the most powerful one-liner you can crank out with awk?
Right.
Yeah, and that was exactly what we were up to with
dtrace for sure.
Yeah.
Yeah, it's so funny to think about that exact same kind of echo. Because Tom, that's the summer of '77.
Right.
And so, we're like, God, actually, what's amazing, Adam, is it's only like,
I know, it's crazy.
It's only like 23 or 4 years later that we're doing that.
I know.
Like 1977 is almost closer to when we were developing dtrace than when we were developing dtraces to now. That's not quite true, but that's close.
That's right. That is insane.
But it's this interesting kind of echo. And there was I remember the Sun CTO, actually, Greg Papadopoulos, I really like, despite the fact that despite NEA's view on oxide. Sorry, Greg. But he had this line that he felt that just to your point about the domain-specific language, that the biggest advances in computer science had a language that went with them, which I think is actually really interesting, right? Because you see that in CUDA with NVIDIA and the GPGPU. I mean, certainly we see it where things that we're excited about, like BlueSpec. I mean, obviously, I think Rust is a big deal, but I think it's like, I'm not a PL person, but it's really hard for me to deny that language is really stitched in closely with our biggest innovations in computing systems, not just computer science.
It's just too damn hard to figure out how to use something without the language to guide you.
Yeah, it's something like that. It's where it's like you need that domain specificity. It guides you, Tom. That's an interesting way of thinking about it.
But there's an interesting lesson there in terms of the survivor bias, and that statement, which is, not every new language has that kind of durable, like persistent effect. Is anyone hearing this very strange buzzing? Anyway,
no,
but that's just me.
No, that's the microchip that Josh planted in your brain that he's activating.
I was just going to say, I hear you talking. I mean,
right, same thing. But like the languages do persist, like have this long shadow. But having a new language can mean your technology is very hard to adopt.
Actually, this is also one of the things that, and I know, Adam, you and I both love proc macros. I don't know how, like, Laura, Josh, Laura, I know you've got that. You've got to have the same love of proc. I mean, I just feel like proc macros in Rust are going to allow for a new level of domain specificity that's also rigorous. Am I?
Yeah, I mean, it's like you're going to be able to do amazing crimes and other things. I think at the same time, right? I mean, it's like some really depends on your point of view when you pick up that tool, I think.
So diagnosing, I'm not a Rust person, but I had like a brief experience with Rust. But diagnosing error messages with the way macros expand is somewhat difficult.
Ooh.
And I sort of I get the power of macros.
I think that's
right?
every language with macros, though.
No, it is amazing in Rust.
Rust
it's amazing. It's amazing. We're about to be very on brand.
Rust makes a heavy use of macro in a way that I've really never seen in any other language. And the thing is, macros in Rust expand into things that the compiler can handle really well. Like, I don't know the details, right? All the way to like how structs are layered in memory and whatever. But that kind of macro system is really needed across all compiled languages. Like C++ needs that a lot. Like if you ask any like GLSL folks, like anybody who's like interested in like staged meta programming, a lot of GPU folks may relate to that, and they may appreciate Rust's macro system. And there are a bunch of C++ efforts by say like NVIDIA folks who try to do like const expr. That's like future of const expr in C++. Like, I don't necessarily like follow that the kind of use cases that I program doesn't involve those kind of things. But so it's like meta programming is like generally is like a very difficult language.
It is,
problem.
but so the error messages you can get in, because I think historically you're onto like a big historical problem, namely when you've got errors in that macro expansion, how do you?
Well, I personally got super confused. Like my experience was with this library called Salsa, which I needed it for
So you
things between build systems and so on. But it's sort of like a
you'd be interesting to take it apart, because I can tell you that the Rust, from the proc macro, from the Rust language perspective, gives macro authors incredible power to generate ridiculously good error messages. I mean, error messages that are, I mean, honestly, I found it eye-popping. Adam, it sounds like you had a similar kind of experience.
Absolutely. I mean, I think on one hand, I totally agree with the statement that you can create macros that are completely undebuggable, where the error message that you get will be indecipherable compared with what you had typed into your program. On the other hand, the latitude that you have to know what span, like what section of code the user typed in was responsible for a particular input value, to be able to correlate with the compiler and say, please underline this statement and print out the following value.
I didn't
it's
Morally,
amazing.
we call them proc macros, but it may be better to think of them as compiler plugins, really. Right.
I didn't even know like the thought went into that in Rust, because I didn't know like people have thought about like error handling at the macro macro level.
It's amazing.
So I guess like I'm in for a great.
Yeah, it is.
You're effectively writing a Rust program that has access to the parse tree and the token stream, right? I mean, and can then control the compiler's behavior and its output.
And then on top of that, when it has bad input, it sounds like Adam and I had the same reaction to the same thing, namely your ability to underline within a line the particular span that actually caused you to not be able to continue processing. And it's just like crazy what we can do.
And then on top of that, the Rust compiler will also, present to the user, this is what the macro told me what was wrong, but tell you what, I don't necessarily know this guy, so I'm going to tell you what I think is wrong too. So even as a macro author, you can't override the compiler. You can only amend, try to specify in greater detail what's going on, but the compiler is going to tell the user its honest thoughts as well.
And I think
so is it fair to say that Rust thinks the quality of life of a macro user is more important than the quality of life of a macro writer?
I think it does not want to pick between its children, but it thinks that both are very important. And in particular, it thinks that the debuggability of macros all around are very important. It thinks it's important to be able, and I can tell you from having done things that were much less powerful, but as powerful as CPP could do, the C preprocessor, where you got none of this. And, we made use of preprocessor very heavily, and I've made use of the preprocessor heavily in lots of things. And you've got no net, and what you can do is
it's completely hygiene free.
Yeah, it is it is so non-hygienic that I kid you not, I did not know how to spell hygienic before Rust's macros. I didn't. There's another I in there. It feels like there's only be one I, but there's another I hiding out in there. I'm like, oh well, there you go. That's the filth I've been living in. I don't know how to spell hygienic.
Hygiene?
Well, look. But the fact that you've got this incredibly powerful facility, and I agree, Josh, like it needs a different name. Plugins sounds too, I don't know, sounds too like...
Well, because Rust also has a slightly more hygienic version of the C preprocessor
That's
as well in terms the macro rules macros.
The macro rules macros, and they are great. And you're like, wow, what is everyone talking about with proc macros? I think it's like, I view it as like a compiler channel programs. You've got this like little program that is going to be executed. And it's like when you first start experimenting with it, you're like, wow, is this like legal? Is this? I mean, I feel, this is a language that has made such a big deal about being safe, and that's gonna, wow, it just allows me to be right on the brainstem, and I get to do whatever I want. I mean, not whatever I want, but
it did. Reading about it for the first time, it felt like the forbidden fruit.
It is the forbidden fruit. It really is.
And I think in the same way, we have some colleagues who feel like it should be more forbidden than perhaps we're treating it. Because it does mean, like, when you're writing Algo 68 as your DSL in your Rust program, it all sort of just works.
Presents a formatting challenge for one thing. It's like you've created a different language other than Rust. So how do I even indent that now inside my broader Rust program?
Well, and actually, I think there's a Hacker News story today about effectively writing Python within Rust with a series. And I think we're going to see more and more of this. I think we are going to see more and more.
Python, there's a Java proc macro experience.
Is there on this one?
Surely. And it would be, it's something that would be highly attainable. And I think it's great because it allows, we were just talking about how important it is to have language innovation to Tom's earlier point about like showing you where to go, and to add DSL kind of specificity on top of Rust. I think it's going to be incredibly powerful. I think it's going to be really neat.
All of my subsequent libraries are going to be accessible only through TCL.
There you go. Exactly.
In your Rust program.
I knew you were going to try to punish me with I have written more Tickle on Oxide than I have in my entire career.
It's time to bring back Intercal.
I feel like we are bringing back Intercal with some of the Tickle, because all of the EDA world is still in Tickle.
Oh yeah.
Oh, and
so it's so sad because Jonathan. Sorry, I just have to mention this and then take myself off from this, because Jonathan Turner joined this space, who's like a person who knows a lot about Rust and ergonomics of Rust and various features of Rust. But then they joined the space, but then they left so early. But I feel like they could have had like a great response and guidance about like all the points we brought up about macros in Rust or error messages.
Just goes to show when you talk about ptrace, people.
I know, that's it. I want the analytics. I want to be able to demonstrate beyond a shadow of a doubt that it was vFork. I think that did it. I think
viewership started out at 13 million households, but then after the ptrace discussion, no one came back after the commercial break. So
I think we've been very restrained for the past few weeks to not just have a complete Rust love-in, and I'm sure
I'm proud of the ptrace conversation we had. I got the answers I wanted. So
the feature request there is time series data on who's listening.
I've got lots of feature requests. If we're talking Twitter Spaces, I want to have a lot of analytics, and I want to be able to see the vFork effect as everyone hangs up on vFork.
Known. Right.
Francesco, you're trying to get in here. See me, I'm pronouncing it correctly.
Can you hear me?
Yep.
Yeah, sure.
Whoops.
Oopsie. I was just trying to compliment the thing about dtrace, that we liked it so much. I mean, Plan 9 and 9 front, that we implemented it, not fully for sure, because we're missing stack captures and some of the backtrace caption features. But it's so nice, and there's people that don't like the syntax, but if you can explain it in less than a page, it's useful,
I'm obviously
did Plan 9 contain awk? I know that there were things like make were remade with less vowels and stuff. Obviously,
it contained the first awk implementation. I think it compiled to C, obviously.
Okay.
And then compiled to Plan.
So I think we are at about, and we're actually a little over an hour. We are unaccustomed to being able to go through the entire hour without having to like reboot and get like chased out of where we were and have to get into a new space. But it worked. So hey, kudos to the Twitter Spaces team. It's getting better, I think.
Yeah.
But
I can still touch my phone. It's not melting my fingers.
And I know we said this last week, but I think we mean it this week. That we are going to want to talk about Silicon Cowboys. We'll kick off with Silicon Cowboys next week. I know that Steve Tuck, our boss, wants to join for that discussion, and couldn't make it today. He's working on a board deck, which is definitely much more important. But Steve wants to join us so we can talk about Silicon Cowboys and Compaq, which is a super interesting kickoff. So we will do that next week, I promise.
Was that the Netflix documentary, or was that a book?
It is there's a book called Open by Rod Canyon, which is also worth reading. And there is I believe it is on Netflix. The documentary can be found on Netflix.
I think I've seen that one. It was good.
It's good. It's worth watching with the fam too. It's a good watch for sure. A lot of it still rings true.
And they thought they had a bug for bug compatibility issue too.
Yeah, they definitely did.
Yeah.
They definitely did. Adam, any parting thoughts?
Really looking forward to next week because Silicon Cowboys is awesome and touches on exactly as Tom was saying, these kinds of like systems problems of making magic layer and making your system look like somebody else's.
All right. Hey, thanks so much, everyone. Really looking forward to next week. But we're having a blast doing this. Hopefully you are too. And hopefully we'll see you next week. Take
Thanks,
care.
everyone. See you next week.
Bye.
Yep.
Draw.
Goodbye.